Hello dear students, I am Tejinder Kaur and welcome to the YouTube channel of IGNOU Study Center 2206. This video is for BCA first semester basic mathematics students. The course code is BCS-012. In this video, we'll learn about matrices. We'll start with their introduction, then types of matrices and then transpose of a matrix. We'll start with the definition of a matrix. A M cross N matrix A is a rectangular array of Mn real or complex numbers arranged in M horizontal rows and N vertical columns. We denote a matrix by a capital letter and its entries are denoted by small letters. In general, an entry is denoted by Aij, where I it stands for the ith row and j it stands for the jth column. So the first entry, which is in the first row and in the first column, is denoted by A11. Similarly, the next entry is A12. It is in the first row and in the second column, and so on. Next is the dimension or order of a matrix. It is determined by the number of rows and columns of a matrix. If a matrix A it has m rows and n columns, then we denote its dimension or order by m cross n and we read it as m by n. Let's take an example. The matrix A, it has 2 rows and 2 columns, so its dimension is 2 by 2. Similarly, the matrix B, it has 2 rows and 3 columns, so its order is 2 by 3. Note that the number of elements in a matrix is the product of M and N. Next is the type of matrices. First is a square matrix. A square matrix is one in which the number of rows is equal to the number of columns. Here, the matrix A, it has 2 rows and 2 columns, so it is a square matrix of order 2. Similarly, the matrix B, it has 3 rows and 3 columns, so it is a square matrix of order 3. Next is a diagonal matrix. It is a special type of a square matrix in which Aij is equal to 0 for I not equal to j. For this, we need to know about the principal diagonal of a matrix. The principal diagonal of a matrix contains the entries A11, A22 and A33. So for a diagonal matrix, the off-diagonal entries, that is the diagonal entries or the entries which are not on the diagonal are 0. Next is the scalar matrix, a diagonal matrix for which all the terms on the main diagonal they are equal. That is, all the entries on the principal diagonal should be same. And if I take all the entries as 1, that matrix is denoted by unit or identity matrix. So it is a scalar matrix whose diagonal entries are 1. Next we have row matrix or column matrix. A matrix with just one row is called a row matrix and a matrix with just one column is known as a column matrix. For instance, here the matrix A has only one row, so it is a row matrix, and the matrix B has only one column, so it is a column matrix. Next is a zero or a null matrix. A matrix in which all the entries are equal to 0 is called a zero matrix. Next is the equality of matrices. We say the two matrices A and B, they are equal if the number of rows in A is equal to the number of rows in B and the number of columns in A is also equal to the number of columns in B. Also, the corresponding entries in both the matrices should be equal. So let's take an example. We are given two matrices A and B and we need to find the value of x and y so that A is equal to B. Here we can see both the matrices, they are of order 2 cross 1, so they can be equated. For this, we'll equate the first entry, that is A11 entry of both the matrices. So x plus 2 is equal to 4 minus y. Similarly, the A21 entry of both the matrices, they are equated. So 3y minus 7 is equal to x minus 3. On solving these two equations, we'll get the values of x and y. Next is the transpose of a matrix. The transpose of a matrix is obtained by interchanging its rows and columns. So we are given a matrix A. If I change its first row to first column and its second row to second column, we'll be getting the transpose of the matrix A, and it is denoted by A dash. Next are the symmetric and skew symmetric matrices. They are a type of square matrices in which the A transpose is equal to A. That matrix is known as a symmetric matrix, and if A transpose is equal to minus of A, that matrix is known as a skew symmetric matrix. Now you can try the various questions given in this block. Thank you for joining in.